Our notes for parallelograms and rectangles. Our content objective is you will apply properties of parallelograms and rectangles to determine the measures of sides, diagonals, and angles missing in the figure. So let's look at some definitions first. A quadrilateral. Quad means four. Quadrilateral is a closed figure formed by four segments intersecting at their endpoints. An example would be something like this, a four-sided figure, closed. A parallelogram is a special quadrilateral in which opposite sides are parallel. They use these little triangles on each side to show that the one triangle and the one triangle, these sides are parallel, and the two triangle and the two triangle sides, they're parallel to each other. So opposite sides are parallel to each other in a parallelogram. We'll see some other properties about parallelograms later to help us find for missing sides and angles. Rectangle is a parallelogram with four right angles in it. So you'll see some special properties about rectangles. Since it is a parallelogram, all the properties of parallelograms will be true. For instance, we know that opposite sides in a parallelogram are parallel, so that's true in a rectangle also. And what is a diagonal of one of these things? A segment joining opposite vertices in the polygon. So I've drawn the diagonals in red. They're going from one vertex to the opposite vertex. And there's two of them in a quadrilateral. Example 1 here. Look at the picture of this parallelogram. Again, we can see the little triangle showing that the opposite sides are parallel. The four vertices, or the corner points, are M, N, O, and P. To name a parallelogram, you're going to use these four corner points. Wherever you start, you just go around clockwise is the best way. So I started at N, and then went to P, Q, and N. Oops, N, P, M, N, P, Q. Okay? You could have started at N and P, Q, M. It doesn't matter where you start, just as long as you go around it in order. Put a little parallelogram symbol. Opposite sides. Well, if I have side MN, which side is opposite to it? The one over here, PQ. The other pair of opposite sides, which are parallel, NP and MQ, opposite over here. Opposite angles. Which one is opposite angle M? Well, it's over here, angle P. So M and P are opposite of each other. And that's how you draw the diagonal too, to opposite corners, or opposite vertices. And the other pair of opposite angles are N and Q. There's something special about their measures. We'll learn that in a little bit. Now, consecutive angles. Consecutive means one right after another. So if you look at M, they're right next to each other, not the opposite one, but M and N are consecutive. And then I go around it, N and P are considered consecutive angles, one right after the other. Well, P and Q, and then the last pair, Q and M, are also consecutive. Special property about consecutive angles too, and their measures. And then the diagonals are from M to P, drawing a segment there. And the other diagonal goes from N to Q. Now here's a list of the properties of parallelograms. You'll be using this a lot in your when you work out your problems. It says opposite sides are parallel. We know that because it's a parallelogram. Therefore, they have the same slope. I don't think we'll be doing any slope problems, but yes, this side and its opposite side have the same slope or slant. That's why they're parallel. Same with the top and the bottom. Opposite sides are also congruent. If I put a congruent mark, this side is congruent to this one, the one opposite. And this side over here is congruent to its side opposite. They're the same measure. Opposite angles are congruent. Now I've got the diagonals drawn in here, but if I looked at this angle right here, this whole angle, not chopped in two pieces, but This one would equal the one opposite, this one over here. They would have the same measures. And this one here would have the same measure as its opposite angle over here. And then we get two consecutive angles, one right after next to each other, are supplementary, which means they add up to 180. So if I took this 1 mark angle here and this 2 mark one right here, they're consecutive, one right after that. They're going to add up to 180 every time in a parallelogram. Same with this one and its consecutive one. These two add up to 180. And you can go around. If they're right next to, or side by side there, consecutive, they're adding up to 180, whereas opposites are congruent, consecutive are supplementary. And then about the diagonals, it says the diagonals bisect each other, which means they cut each other in half, which also means that if this one's cutting this long one in half, that means this piece right here, I'll mark it with 3 marks, equals this one right here. These pieces are the same. And then this one right here cuts the smaller one in half, so its pieces, 1, 2, we'll mark it with 4 marks, 3, 4, is the same as this piece right here. Now the whole diagonals are not equal to each other, but their pieces are, because they cut each other in half, they bisect each other. So we use these properties to find missing angles like this. So you look at it, let's see, I know this angle is 135 and this one right here, R, is what they want to know. So those are opposite angles. And our property says opposite angles are congruent, so this angle is 135 also. Opposite angles are congruent. Here in this picture, these aren't opposite angles, these are consecutive angles, and they have to add up to 180. So if I take 180 and subtract 70, I get 110. Double check, whoops, that's a 0. 110 plus 70 is 180. There you go. Now for example 2, we look at this. What do we got? Kind of want you to write a statement, what you're thinking here. So if ABCD is a parallelogram, and so let's draw that. Here's my parallelogram. And just label it. I'm going to start here and go A and then go around clockwise. A, B, C, D is fine. Okay? If you started up here with A, that's fine. This would be B, this would be C, this would be D. So the measure of angle A is X. And the measure of angle D is 2X minus 3. So what's true about these two angles? Well, they're not opposite angles, they're consecutive angles. And what's true about consecutive? If you don't remember, you look at your notes. You know, first you pick out what kind of pair they are, then look at your notes. If you don't remember, the consecutive angles are supplementary. They add up to 180 degrees. So that's our equation for this one. That angle A, which is X, and the measure of angle D, which is 2X minus 3. We add them up, it's going to equal 180. And we go ahead and do our algebra to solve it. Combine the like terms there. 2X plus 2X is 3X. And then we'll go ahead and get rid of this subtraction first with addition, and then get rid of the multiplication with division, and we end up with 61. X equals 61. And then you could actually, they don't ask for it, they just wanted you to solve for X, so find X. If we needed to find the measures of these two angles, we could put it the 61 in it for X for each of these and figure out how much each one is. Quick check I'm not going to do. I'm going to consider that part of your practice problem, so you can go ahead and do that. If you need some help, let me know. Otherwise, I'm going to go to one more example in this. Let's see what we got here. This one right here, example 3, and then that'll be the end of part 1. So I've drawn the picture here for you. The diagonals XZ and YW that intersect at a point A. So here's my parallelogram XYZW, and then I drew in the diagonals and called that point where they intersect right there A. And then it says from X to A is 3M, so that's right there. And from Z to A, that other piece of the diagonal is 5M minus 4. So we know that the diagonals bisect each other, cut each other in half. So these halves are equal. Those pieces are equal. So the 3m equals 5m minus 4. Alright, so I'm going to get rid of these 5m's. I don't want m's on both sides. So when I subtract that over here, I get negative 2m, and there's a negative 4 left here. Divide by negative 2, and I get m equals 2. Okay? If I go too fast, just pause it. Alright, that's the end of part 1. That was long enough. I'll do part 2 in a little bit.